Today we're going to talk about the Hall systems, mechanical advantage Hall systems, raising systems. We're going to run through a modified version of the Arizona progression, running through a like Georgia Hall with a redirect through 3-to-1s into a compound 9. Then we'll take a look at the inherent difference between 2-to-1 or even numbers against say like odd numbers on 3-to-1, 5, 7, 9-to-1. So we're going to start out with some of the hardware that we use. Let's bring it in a little bit. We're going to take a look at some of our pulleys here. So pulleys come in all different shapes and sizes. This is the Rock Exotica pulley. It's a triple action insofar as I've got to press the plate and or press the little button, slide the plate open, then press it and slide it again. Very nice pulley, high efficiency, 36 kilonewtons or 8,000 pounds. And it's got a swivel. Allows me to load it hands-free compared to a Prusik minding pulley. Prusik minding designed to run with a Prusik has this straight edge. Rock Exotica also has it just on the one side. You get such as the Petzl Prusik minding pulley, slide the gate open, place it on the line. Then we come into rescue pulleys, big, large, heavy steel rescue pulleys. These are from CMC with a 4-inch sheath, very high efficiency, and rated, like I said, for a rescue load. This one is a Beckett pulley. Here's the Beckett down at the bottom, or a double pulley, insofar as it has 2 sheaths through the middle. Prusik minding Beckett pulley, again double pulley, has the Beckett on the bottom, and then we have an ID. Some persons might think the ID is out of place amongst these pulleys, but the truth is you can utilize an ID to obtain the same configuration in the Z-rig as you would for a 3-to-1 mechanical advantage. You're not going to get a 3-to-1 because there's no moving wheel in the bottom, just a cam, and that's going to create friction. You're going to be closer to around a 2-to-1 when you build a 3-to-1 with it.
The rescue senders are hard grabs. Work on a camming action, more mechanical, essentially pinching on the rope. So our soft grabs work on more of a, we're pretty familiar with those, but just a cinching action. Our Prusiks will start to slip around 3,000. In the ballpark, 3,000 pounds, and will eventually catch. These can eventually, if loaded hard enough, damage the rope. The ones we do want to avoid using on a Hall system are like our hand descenders with the sharp teeth. Those we want to keep away from heavy loading situations. So, cost, obviously, these are a lot more expensive. Then the Prusik is a lot cheaper to grab as well.
Rule number 1, to create a mechanical advantage, is when you're utilizing pulleys and connectors, if you add a pulley into the system, does the pulley move? So when we look at this pulley here is attached to our anchor point, and it doesn't move. So in this case, we do not have a mechanical advantage. In order for the pulley to move, it would need to be attached to the load. Once I establish if my pulley moves, let's say it does, and then I want to estimate my mechanical advantage, I'm going to count the legs to the load. Here is our load, and we have one line going to the load. So we have a mechanical advantage of 1-to-1, basically no mechanical advantage whatsoever. In fact, we have friction. And all that is doing is allowing us to change our direction of pull, allowing me to pull towards the load instead of standing on the other side and pulling away from the load. All right? So that's our mechanical advantage. If you can vision this in the vertical, it would allow me to pull down instead of otherwise pulling up. What it does have on it are these 2 Prusiks. These are very important. As you can see, my working end is still under tension. So my Prusiks here serve as a progress capture, so that when I haul on the line and I release, it captures my progress. If I have 200 pounds on this line, that means in order to raise him, in order to affect travel, I have to apply a force of 200 pounds on this line. That means if I have 200 pounds on this, and 200 pounds on this, at my anchor point, I have 400 pounds of force. You need to take that into consideration. You need to understand that whatever I apply here means I have to have the same here, and therefore whenever I apply here is doubled here. Make sense? So we have three basic types of mechanical advantage. We have simple, we have compound, and we have complex. Under the NFPA 1006, under Chapter 5, the JPRs, if you specialize in something, such as MVC or motor vehicle collision response, you have to know how to build a simple 3-to-1, for example. At the Rope Rescue Tech Level 1, you have to know how to build a compound system. So we're going to take a look at simple systems, and then we're going to work through compound systems. The first thing I'm going to do is attach a grab to my line, or I can bypass it and just attach straight into this carabiner, but I'm not going to. I'm going to attach a grab to the line. That's going to allow me variations. It's going to allow me to change certain things. To bring that to where I want, let's say Todd might be there over the edge of a building. I might not be able to connect to him. I'm going to add in a pulley, and now you see that the pulley moves. Back to our first two rules. Rule number 1, does the pulley move? In this case, yes. Rule number 2, how many legs to the load? This becomes our load point. We have 1 leg, 2 legs, 3 legs into the load. Therefore, we have a mechanical advantage of 3-to-1. Attach it directly to Todd himself. You can see there's our 3 legs to the load, our mechanical advantage. The problem with doing this like this is in order to raise Todd up 100 feet, I have to have 300 feet of rope. If I'm getting a mechanical advantage of 3-to-1, I have to pay back, and that means I need to pull 3 times the actual distance that he will travel. As you watch here, as I raise this, I will travel a lot further than Todd does. And down slow. In order to affect the lower, I have to manage, go down slow. I have to manage the process, and I can just let it down slow. The minute I let go of the progress capture on the process, keep on going, it will self-lock. Okay, let's re-affect our 3-to-1 through the process. Now, I want to convert this into a compound 9. Let's take a look at some of the things, some of the options that I have. The next pulley, if I add one in the system, has to get added at the anchor point. Really nowhere else for it to go. There is. Then I'd be building a complex, would that be a complex 9? Complex 9. Look it up. We're not going to talk about that. That's for a different lesson on a different day. So, I'm going to add another pulley to my anchor system. And what's my mechanical advantage now? Let's ask the 2 questions. Does that pulley move? No. Therefore, I did not increase the mechanical advantage. How many legs to the load? 1, 2, 3. Therefore, I still have a 3-to-1. So, even though I've added a pulley, all I've done, once again, is change my direction of pull. If, however, I now add a pulley at this load point, I have 2 options. I can add it directly here, Now I've added a pulley that moves. So I've increased it. How many legs to the load? 1, 2, 3, 4, 5. I have a mechanical advantage of 5 to 1. All right? What happened to 4 to 1? We'll get there. So bring it in. Look how much line I've got to pull to affect movement on Todd. Barely moving, and I'm taking up a lot of line here. Ready on down? Down slow. All right. If I only had the one pulley, but Todd had just made a rescue, and I was all by myself, the 5 to 1 mechanical advantage might not be enough. So I have the option, utilizing a compound system, to create a mechanical advantage of 9 to 1. And instead of attaching it on that former prusix, I'm now going to attach it on the last, I'd say running end, but I guess it's still a working end, leg of my whole system. And what I have, if you can see this, depending how good Sandy's camera work is right here, I have a 3 to 1 pulling on a 3 to 1. There's a 3 to 1. And right there, just these 3 legs, is another 3 to 1. So we say 3 times 3, not 3 plus 3. 3 times 3 gives us 9. So I've gone from a 5 to 1, positioning the pulley here instead of here, and now I can, with one pinky, resist. I can bring Todd in with no effort whatsoever. But I have to pull through a lot of rope. I have to pull through 9 feet of rope now to affect 1 foot of travel. All right? Simple to compound. Okay. We'll take a quick break here. Then we're going to look at the simple 2 to 1, how the 2 to 1 differs from the 3 to 1, and how to turn that into a compound 6 to 1.